Lab 11 talks about partitioning. In this lab, we are going to understand what is the technique we use in partitioning and how the partitioning helps. We will see how to divide a table into smaller pieces, okay, and name each piece a partition so that on requirement, instead of searching the whole table for a specific value, we can go only to that specific division or a partition and search. For example, we have extra stores in KSA which have so many branches. And for example, if I want to check what are the offers running in Alhassa branch, so what I can do is divide the whole extra database into different partitions based on locations. For example, we can have one partition assigned for all these stores and their details and their customers in Alhassa partition. Similarly, the details about the customers, the store, the products in Riyadh can be assigned into a Riyadh partition. So, if you want to check what are the offers in a specific region, you can go to that particular region partition and search instead of searching the whole, KSA database. So, this tremendously decreases the time of searching and overall managing the database by only focusing on a particular partition. Okay, so with this example, we understand that the partitions can be created, okay, by some strategy. It can be divided by range, by list, or by hash. We are going to see these two things in the lab. Okay, now some more details about partition is that it comes with the enterprise edition only. Okay, it comes with the enterprise edition only. It doesn't come with the standard edition or express edition. This feature is not supported in SE and XE. Okay, or XE version of Oracle's. Okay, partitions like an hard disk. For example, I have an hard disk here for my computer, and if you see, my hard disk is divided into two partitions, C colon and D colon. Okay, by dividing things in different partitions, by dividing my hard disk in different partitions, it only helps me to sort and store the data in a better organized fashion. For example, all the things related to applications, I store it inside C colon, installation or apps, I put it inside C colon, whereas all the data I put inside the D colon. Now, what is the advantage of doing this partition? Is that if my this two partitions starts behaving like independent disk, if one part is damaged, it doesn't affect the other partition. That is the main benefit. Another one is it helps me to store things related to data or applications in different partitions. So similarly, the Oracle helps us with the partitions. Okay, so let's see how do we do that. The partitions offer three basic data distribution methods. Okay, and we can partition or group the partition by the following techniques, following ways: in a form of a range, in a form of a list, in a form of a hash. Okay, now the partitions what we create can be a single partition. Okay, how does a single partition look? For example, I have created a table, okay, and I have created one partition inside it. That's it. There is partition by range. Okay, and inside this partition, I'm specifying two ranges. Okay, now I can have, for example, um, here is another example of a single partition. I have only a single partition here called as department. Inside department, I am naming it the different departments. Okay. Here in the third example, we are creating a composite partition. What does it mean? It means that I have more than one partition inside it. Partition 1, partition 2, partition 3, and they are all inside one big partition. So a partition inside a partition is also possible. For example, we have a big university. It has different partitions called as colleges. Each college is again having different departments. Okay, so a partition inside a partition is called as a composite partition. Okay, so now let's understand the index organized tables, also called as IoTs. Index organized tables can also be partitions. Okay, so indexes can also be arranged in a form of partitions. Okay, let's see how to create a table with a partition. Now, in the exam, you will get a question like this: create a table, students, okay, with the fields as number, ID, number, name as varchar, and a grade as a number. So this is the simple process: create student, mm, create table and name of the table, and you specify the columns and the data types. But this is unchanged. This is the pretty same way we have been using to create an SQL table. The additional thing what you do is you do not give a semicolon here. Now you start doing the creation of partition by using the word keyword partition and the type of the partition. So partition by range, okay, on which column do we want to have this partition done. Okay, so this will be specified again in the question. It says that create a table and partition it by range, okay, using the grade field. So I want to create a partition in a for the DBMS students who got the grades less than 60 and who got the grades greater than 60. So it is important for me to identify the grade field. Okay, so I'm going to pick up this grade as my partitioning factor. Okay, and what is the type of the partition that I want? I want it to be the range. So all the grades which are ranging from 0 to 60 will be considered as one group or one partition, and its name will be G1. And the other one will be G2, which will have the grades greater than 60. So I'm going to say partition by range. Okay. I will specify the name of the column here. So the range partition should be created on grade column for the values ranging from 1 to 60 and name it as G1. Okay. And the other one, name it as G2. Okay. Are we understanding? So it creates two partitions, one 0 to 60 and then, above 60. Okay. So here it means values less than 60. So 0 to 59, you can say, and then 60 and above. So you can use, different logical operators here. Okay. So this is how a table is created with two partitions, and the type of the partition is specified at this clause: partition by range, partition by list, or partition by hash. Okay, now let us see another example. In the other example, it is asking us to create a table student. Okay, now you need to create another table like student one, for example, because we created it already. So create table student one, students one, okay, or student 62. Okay, okay. So again, the column creation and specifying the data types. Okay, now here it says that partition by list. So we are going to say partition by list. Okay, and we are going to say use the department field. So partition by list, use the department field. Okay, on department. So here my partitioning factor is department. Okay, because I have this department field here, department. Okay, and I'm going to name S1, partition S1 as IS. Okay, now IS is like a literal name for first partition, and the second partition S2 as CS, and the third one partition as CN. Okay, so here we are creating three partitions and we are listing them. Okay, so it's like a student is inserted, a student record is inserted into section 61. Okay, and if she belongs to department IS, she will be inside the IS partition. Okay, and if a student details are entered into the student section, student 62 table, and she belongs to CS, so her data will be, organized or stored inside the CS partition. Okay, so are you understanding? So it's like behaving like a list. Let me draw. For example, if you have a big table and you have so many rows inside it, and based on, for example, here we have department. Okay, department can be IS or it can be CS or it can be CN. So based on this, what happens? This big table is divided into three partitions. Three partitions. Okay. One is IS, one is CS, one is CN. And based on the values, they go, okay, this doesn't go here. This goes here, and this CN goes here, and IS goes here. So it will become easy for me to search any student from CS. I will just look into this table, this part of the table. If I want to search for any student in CN, I will not go to this partition. I will not go to this partition. It will save my time. I will just come here and search. Okay. So this is what we learned in the second activity. Okay. Now let us see the third one. Uh, Let me rub this. Okay. Okay. The third one is an example of a composite partition creation, wherein we have one big partition holding many smaller partitions inside it. Okay. So let's see how the question will be given. So it says that create a table, students, okay, all, for example, with the field, student number, name, department. And now we have city. Okay, so this is the extra thing. Okay, partition it by list, okay, using department field. So we are going to create a partition by list in with the department field. Okay, and sub partition, okay, create another partition inside it by using the city name. Okay, so name the partitions and sub-partitions as you like. No worries. Whatever you want, you can name them. Remember that there will be three partitions, okay, and two sub-partitions, okay. Three partitions by department. So because we have three departments, right? ISCS and CN, and two partitions, one for the students of Riyadh, another for the students in Al Hassa, with all these three partitions. So you're going to create a table section, create a table, students all. Okay, this is the table name, and we have the columns. Okay, and we are going to say partition by list department. Okay, inside this, we are going to create a sub partition by the list again and based on the city. Okay, one partition for department, another partition for the city. Okay, so it's like creating a big partition, partition by list, okay, departments. And sub partition is done by city. So it's going to be like this. The sub partition is opening here and closing here. It's opening here, sorry. Okay, and closing here. Okay, now this there are how many subpartitions? There are uh, two subpartitions, right? There are two subpartitions, as we said here. There are two subpartitions. So we're going to say one big partition. This is going to have is going to have uh, this is going to have one subpartition, okay, and this is going to have partition S1 for IS, partition S2 for CS, partition S3 for CN, and each partition of IS will have students from Hufuf and students of Riyadh. Okay, okay. So it's something like this. Let us draw and understand. Okay, so we have, let me draw it. Okay, so we have very big table for the university divided into IS. Now this IS is again going to have a partition. for Riyadh students and for Al-Hassa students. Are you understanding now? Now, same thing will repeat for CS students partition. Okay, and this is going to be divided for R students. So we have an R student partition here and H students partition, Al-Hassa students partition here. Okay, so and the same repeats for CN. Okay, so like this is a big partition. This is the big table, sorry. Okay, this is a big table. Let me take another color. Where do I have a color? Okay, so um, let me take this one. Okay, so yeah, this is your IS partition. This is your CS partition. This is the CN partition. Okay, each partition is having the sub partition. This is the sub partition. The sub partition is by city. Okay, so that's it. We have created three partitions, and inside each partition we have two sub partitions, and this is how we create the sub partition. We use the reserve word sub partition. We use the reserve word sub partition, okay, to create a partition inside a partition. Okay, so this is how you create uh, three partitions. Okay, this is the first partition, this is the first partition, this is the second partition, and this is the third partition. Okay, and the partitions inside it becomes the two smaller partitions for for organizing or storing the students from different cities. Okay, so here we are mentioning that the partition should be by department, sub partition should be by city. Okay, so this is the thing. Okay. That completes our discussion for Lab 11. Thank you.